Hello guys, welcome to solving 100 problems in JavaScript. In this series, I will be solving 100 programming problems in JavaScript. The idea of this series is for you to learn some JavaScript and then some of the modern concepts and features that were introduced to JavaScript in the latest specifications and standards, like the ECMAScript 6 and 7. So the first problem that you would be solving is binary reversal. So we'll go through this problem, which is here on my blog, and then we'll try to break down the problem into a series of steps and then try to solve it. So let's dive into the problem and see what it's all about. So the problem says that given the function binary reversal, take the str parameter being passed, which will be a positive integer, take its binary representation padded to the nearest n times 8 bits and reverse that string of bits. Finally return the new reverse string in decimal form. So they have given a few examples, and the first example would be if the string is 47, then the binary version of that integer is 10111, but we pad it to 00101111, which essentially means so whatever the string representation, the binary representation we have, we pad it nearest to the n times 8 bits. So in our case, the nearest is 8 bits, and we have like 3, 4, 5, 6 bits, and the other two we pad it with zeros. So your program should reverse this string, this binary string, which then becomes the reverse version of this essentially, and then finally return the decimal version of this string, which is 244. So we convert this to decimal again, and then it's 244. And then there is some other examples, which is 4567. If you feed this into the function, it should give you 60296, and 213, if you feed it to the function, it should give you 171. Yeah, so this problem, I think we can break it down into 5 parts, which I have done here, and then we also have some assumptions. So the assumption is that the string will be a positive integer that is being passed into this function. So yeah, the breakdown is, so one, convert this string to its equivalent binary representation. That is one thing we have to do. Pad it to the nearest n times 8 bits. Reverse the resulting string on step 2. That is, whatever we get from here, we reverse it, or like invert it, and then convert the string on step 3 to decimal, then return the resulting string. So let's dive into how we can code these steps and see what we get. Let's see how we can put this breakdown into code. And the first thing we have to do is convert the str to its equivalent binary representation. So let's open up a VS Code instance, and here I already have a function binary reversal, which accepts an argument str, and we also export this function. So the reason I want to export this function is to do our tests, which we can individually import the function and then just run a few bunch of tests for that function. So in this, I want to see if it actually returns what we want for the input of 47. So what we want it to return is, let's see. So on the example, they have given it is str is 47, we want to get an output of 244. Let's try to test that. Expect. By the way, I'm using jest to test. There is a bunch of options for you to use a testing framework. I prefer jest, but it's up to you guys to use any testing framework. Let's see how we can test this. So what we want to input here is 47, and then we do expect the return to be equal to to 244. So let's run the test and see what we get. As you can see, it failed, and we have got an undefined instead of the 244 that we expect. Yeah, which is fine because we haven't really returned anything here. So we can return the string itself and see if the test changes. Yeah, so if you return the same thing, it's again failing, but this time it's saying it's got 47, whereas it expects 244, which is fine because we still don't have the implementation. Let's see how we can do the implementation here. So converting the str to its equivalent binary representation could be done the following way. So we have the code here, and what we can do is declare a new variable called binary equivalent, and then the JavaScript offers you a pretty easy way of converting this to its binary equivalent. So what we can do is to call toString and then pass the base here. So this should actually give you the binary equivalent. So let's return this and then try to see if we get what we want here. Yeah, so what we received was the actual output of the function was this. So it's 1 0 and 4 ones. Can check if that is the exact thing that is specified here. So 1 0 and 4 ones, yeah. So I think that covers the first part of it. So let's try to code the second part of it, which is padding the resulting string from the first one to the nearest 8 bits. So essentially what we want to do here is get the amount we have to pad and then add a bunch of zeros to it. So let's try to declare a variable. All padding length, and then we can try to so the padding length is going to be 8 minus the binary equivalent length modulus 8. So exactly. So what's happening here is this modulus operator is it tries to divide the binary equivalent length. Dot length is going to be 6 in this case because it has 6 characters, and 6 divided by 8 is going to have a remainder of 6 because it can't essentially divide by 8, assuming there is no decimals involved. So if that was the case, it would return us with 6. So 8 minus 6 is going to give us 2, which is the amount we have to pad. Let's try to see if we get that. Here, let's return padding length and see. Yeah, so we received 2, that's what we expect. But we have a slight problem here. So this is fine as long as there is a remainder, but if there is no remainder, we are supposed to have no padding. So for example, if this binary equivalent length is 8 itself, we don't have to have any remainder. So by this logic, if it was 8 and the modulus of 8 by 8 is going to be 0, 8 minus 0 is again going to give us a padding length of 8, which is wrong. So to fix that issue, let's try and do a check here. Binary length modulus 8. We can check if it is 0, and if it is 0, we can just return 0. And if not, we can do the other operation here, which is 8 minus binary equivalent dot length modulus 8. So that should cover that scenario there. And then now that we have the padding, we can try and do the actual padding for this binary equivalent here. So to do that, let's declare another variable called padded binary, and what we can do here is, actually let's call this step 1 and this is going to be step 2. More clearer this way. So the approach we are going to do for our padding is, since we already have the padding length, we can do something like this. Yeah, we can do array and give it the padding length, and then fill those with zeros, and spread it. So this spread operator, what it does is, if you have array with a bunch of items that are initialized to 0, it puts them in a in this array, the outer array, as individual elements. So that plus we also want the binary equivalent, the rest of the string that we want. So this is the padding, and then this is going to be the rest. So this is a string actually. We can also spread that as well. So even though there is a string, it would break it up into individual characters and then put it inside this array, the outer array. So yeah, so we have all the things, all the characters that we want, or like the padded binary string in here. So we can do a join to get the resulting string. So there's a bunch of ways which we can approach this one. The reason I did it in the following way is to make the next step easier, that is the reversing part. So let's see. Let's actually run a test and see if we do get the thing that we expect here. Okay, binary length is okay. It's a typo. Okay, it's actually binary equivalent. Dot. Yeah. Let's run the test. So yeah, we do get the padded one now, which is what we expect. And we can go on to step 3 to implement the rest of it. So let's see how we can actually do the reversing part here, which is step 3. So let's go to the code, and in JavaScript it's really easy to reverse something if it is sort of inside an array. So in our case, we do already have an array, and we are just converting it to a string by using a join. But before this join, if we can actually do a reverse, and then join, we would actually get what we want. So we can rename this variable to padded reversed binary stuff. So, and we can actually return that to see if that is what we want. Okay, is this type error? Yeah, sorry, it's actually simple. Yeah, so we received this. Let's check if that is what's in the example as well. Yeah, that seems to be the case. So it's exactly what we want. So the two are the same, and then we want to convert this back to a decimal. So this is actually step 2 and 3 together, quite easy. And then step 4 and 5 we can do both together here. So we want to return a decimal, the decimal of this string. So to do that, we can do pass 8 and then give it the padded string and then
the base which this is on. So in our case this is in base 2. So specifying this should give us this string in its equivalent decimal form. So let's see if we actually get that. Actually the test should be passing now. All this time it was failing. Yeah, it does pass. So that's how you that's a good thing about writing a test. So finally you get a passing test, and you are sure that this is the right approach. You can also add in a few other examples they have given in here, just to see if this is the right implementation. Okay. Let's see, we should equal this, and then there is another one. Should equal and so on. Yeah, so all of those seems to be passing, and okay. You can just slightly change the test, and yeah, this should do it. You can also add in other edge cases if you have. But I think the examples already cover a bunch of edge cases as well. So yeah, that's about it, how we can implement a good solution for this problem we have. Let me know if you have any questions or comments on this sort of approach on the comments below. Yeah, thanks for listening and have a good day.